Hello and welcome. I'm Janali Shade, Product Manager for VMware Tanzu SQL, Postgres and Kubernetes, and here to share the 1.8 release with you all. With backup and restore laying the foundation in our last release, we have been building the blocks for disaster recovery. Another cool feature we have added is the ability to travel back in time, just like Flash could, to correct a user error like a database or table being accidentally dropped. We also now support the Azure Object Storage. The mechanism behind disaster recovery being used is continuous restore. As you can see in the setup here, any backups taken on the source instance will be automatically archived to the remote storage and restored to the target instance. In the event of a Kubernetes cluster outage, if the source instance goes down, the target instance could be promoted to be the primary instance. Let's look at how we can do that. As part of this demo, we are going to set up continuous restore between a Postgres instance that exists on a remote GKE cluster and my local Minikube cluster. First, let's identify the Postgres instance that I'm using as a source for the data. The instance I'm using is Postgres sample and it lives on this GKE cluster. As you can see, this instance is configured to back up to a location called my Azure backup location. To set up continuous restore between my Postgres on GKE and my local Minikube, I'll need to create this exact backup location in my local Minikube. Let's create a backup location secret in my local Minikube as well. For the purpose of this demo, I have included the content of backup location resource and its secret on my machine. I'll go ahead and apply the file. Now that the backup location exists on my Minikube, I'm going to create a new Postgres instance that would access the target for all the backups coming from the Postgres sample on GKE. First, I will get the stanza name of the Postgres instance running on GKE. Now that I have the stanza name, I need to create a Postgres instance that references the stanza name and the backup location that the stanza exists on. I already have a file with this info. Now that the Postgres instance is created on my Minikube, the continuous restore process should resume immediately. This means that any backup taken against Postgres sample instance on GKE will automatically be restored on the Postgres instance running on my Minikube. Using kubectl get, you'll be able to see the last timestamp of the backup that was restored. Let's look at how we can do point-in-time recovery. For this demo, I have a Postgres instance running and a backup location attached to it. I will create a table. Say if I was to accidentally drop the table, I can restore back to a time before the table was dropped. I'm going to take a note of this timestamp to use it later to restore to. Let me go ahead and drop the table I just created. To perform a point-in-time recovery, we need to edit our Postgres restore CR to include the time we would like to restore to and the name of the closest available backup. I have updated the file to include the time I saved earlier and the backup name. Now, all we need to do is wait for the restore to succeed. Now that the backup has completed, the table we dropped has been successfully restored. Thank you.